We are now have our next session. We are pleased to have Daniel Lundin with us. Daniel is a seasoned consultant with a decade of experience in management consulting and interim leadership roles. He specialized in metadata and master data management, including taxonomies and ontologies, and he has successfully driven transformation initiatives that enhance operational experience with the help of structured data. His expertise includes implementing data governance frameworks, integrating acquisitions, and driving change. Today, Daniel, based on all his experience, will be talking about not replacing humans and amplifying their capabilities. So thank you so much for this, Daniel, and onwards to you.
Thank you very much. A very kind introduction, Mark. Welcome, everyone. Happy to see you here. Somewhere in a perfectly average corner of the galaxy, a perfectly average company had a perfectly ordinary problems. They had their machines. They were fast, they were powerful, they were complex. Some of the machines they built were highly complex. They were very powerful, and they were rotating heavy equipment at really fast speeds. The technology was not their problem, and the real challenge was not the hardware. It was the humans. They had experienced technicians that could solve everything. They had intuition, they had muscle memory, and that had a sixth sense for what was wrong. But the new technicians, they were lost in a sea of SOPs, technical bulletins, and tribal knowledge that lives in the heads, not the systems. Management, armed with their spreadsheets, their buzzwords, and a faint sense of panic, did what many do, at least in this day and age. They turned to AI. Maybe a robot can fix it all. But instead of unleashing an all-knowing overlord, they did something radical. They listened to the humans. They bottled their knowledge gently. They modeled it into taxonomies and ontologies with only minor headaches, then let it dance with an unstructured data to create something surprisingly clever, a large language model that didn't replace technicians, but made them feel like they finally read the manual the universe forgot to include. Let's take a moment to think about what we trust with AI today. Summarizing emails? Sure. Designing medicine? Nah, not so much. Now imagine you're selling this industrial equipment. It rotates over 5,000 RPM with immense torque. You want to improve technical support using all the knowledge your company has, your SOPs, your technical bulletins, your customer issues in ServiceNow, and so on. How do you do that without losing the human touch and preserving trust? That's the question we asked, and that's the question we answered. The challenge was clear: a growing gap between experienced and new technicians. The risk, well, if they automated too much, they would lose the tacit knowledge, the kind that only comes from years on the job. And if they did nothing, they would fall behind. The industry was growing. Their competitors were scaling up. They needed a solution that respected the human expertise while still scaling it. The goal was to improve the service quality and planning. Utilization was quite low, or it was really low. They couldn't utilize their experts in the way it was intended. A lot of administrative processes took up a lot of their time, and they were not efficient in their planning and execution. So the process for their service technicians starts with a customer call or an email. Then it goes through some in-house staff and ends up with the field technicians. But each of these steps had its own knowledge silo, and we needed to connect those dots to make sure everyone had access to the same insights. The vision was to create a technician on the shoulder experience, but it faced two big challenges: a large knowledge gap and a lack of time and availability from the more senior technicians. So they turned to AI, not to replace them, but to assist staff in identification of issues, planning, and prioritization. Not only of activities, but also the execution. But the first problem came quicker than anyone had imagined. The data was in no shape to be used. Shortcuts were tried and failed. Believe me, they tried. They realized they had to spend time in creating a good structure for the data in order to utilize that for the AI initiatives going forward. So why was this important? Why did they invest in actually doing foundational work? A lot of work today is done on POCs and prototypes, but never really thinking about the long-term consequences. So, of course, there were risks identified, quite big risks. Doing nothing meant inefficiencies and inconsistent service. A full automation approach risked safety for the customers and the staff, but also risk of morale and adaptability. You needed your staff, your service technicians, your experienced front-facing, customer-facing staff to know how to adapt to unforeseen situations. They also faced hiring challenges. There simply was not enough experienced technicians available. So the solution had to be smarter than just replacing people. It had to preserve and scale human knowledge, and of course, support a growing business. So, how do we use AI to amplify human capabilities? Well, it starts with understanding what LLMs are good at and what they're not good at. They're powerful, but they need structure and context. So LLMs don't understand. They predict. They don't reason. They pattern match. They're not intelligent in the human sense, and they're only as good as the data they're trained on. That's why structure, context, and governance are critical. Without them, AI is just noise. Some additional facts that are important to know before we move on here is that LLMs don't have a built-in accountability. When I'm talking about LLMs, we're talking about the ChatGPTs, the Geminis, and the Llamas of the world. Most structure and context today, which is needed to succeed with any AI initiative, is encoded in personal Excel files. And it's only accessible and understood by the person who's created it. As more and more data is generated every day, the problem just grows by the minute. And on top of it all, we risk losing the people who really understand the system they work in every day. And this is a silent loss of knowledge that turns into losing real money and dealing with real risk. Retirement, reorgs, and resignations, the 3 R's of the risks involved in not focusing on the human element, because the humans is what ties all these things together. So let's imagine this. Most organization data is scattered, and how data, quote unquote, usually works is that you have your data scattered. Excel sheets, emails, legacy systems, all of that stored in different storage spaces. It can be your SharePoint, it can be a file share elsewhere, it can be a database or something like that. But who is it who makes the data work today? It's the Steves and the Norse of the world. I met with them in all the companies I've ever worked with, and they're always referred to by their first name. No matter how big the organization is, everyone knows who Steve or Nor is, and that they're the solution to understanding and using most of your data. So data today is built on humans, not on systems. But how we name things, the language is really important when we move towards LLMs and AI to ensure that the models perform. But of course, we need some flexibility in their language. Consider synonyms, other words for the same thing. They're only relevant if there's stability in how we commonly name things. This means humans need to align and agree on a common language, and then we can start using synonyms. Otherwise, our large language models and AI initiatives are lost. So what happened just now is that from storage, I call this a database. From the Steve and the Nor, I'm calling this a human interface and so on. Language is very important. So what have we been doing these past few years? Well, we've been trying to plug in LLMs to the mess that we have created throughout the years, hoping for magic. But without structure, it doesn't work. We need to rethink how we prepare data for AI, not just collect it, not just funnel it and hope for the best, but actually organize it meaningfully. I've seen the replacement of humans with LLMs, or at least the attempts of so, many times, and always with the same result. It looks good on the surface, but it doesn't hold under scrutiny, and the people in your organization do not trust the result. Why is this so? Well, not all tasks are created equal. LLMs are great at summarizing and extracting key points. But when it comes to hiring, strategy, or life-critical decisions, we need human judgment. I made this slide to help understand where we should and could use AI and where we shouldn't. So, armed with these facts and understanding, what do they actually do? And I'll actually take a step back and highlight the structure here of this slide. The trust column indicates where there is an inherent big or large portion of trust in using LLMs, summarizing an email, highlighting the most important points from a presentation. An LLM excels in this because pattern recognition and extractive tasks is something an LLM is really, really good at. When it comes to managing a hiring process, well, there's no accountability, there's no fairness guarantees, and an LLM cannot match personalities to a corporate culture, for example. And of course, there's a large risk portion with bias, legal implication, and ethical considerations of using an AI or LLM to manage the hiring process. When it comes to the other parts, like designing your go-to-market plan or design and test and produce a medicine, the trust is simply not there. There are too little accountability, too little experience, and too little understanding of context given the memory size of LLMs to actually do these complicated tasks. So back to the question, what did this company do? The approach had 3 steps. First, listen to humans, capture their knowledge. Secondly, digitize that knowledge in a model using things like taxonomies and ontologies. You can call it structures and relations if you want. Third, building an AI assistant trained on that structured data. The method, capture, model, deploy. A few years ago, I would have called it creating your digital twin, and I think this is still valid. But the tacit thing, the thing that you're actually creating is a meta model, and to manage that is actually metadata management. These are 2 concepts and 2 words that I believe will be very important in large corporations, well, medium-sized and small companies as well, going forward if companies want to utilize the power that resides within the trajectory of LLMs and AI investments going on today. So, meta model and knowledge capturing, that approach I think needs some context. So the meta model is built to ensure context, meaning, and insights are captured and stored in a way that it's structured and accessible in a way to enhance the data you have. This is the foundation of trustworthy AI. And trust starts with predictability and accuracy. Predictability requires knowledge. Knowledge comes from structured data with meaning. And structure comes by utilizing concepts like taxonomy and ontology, ways of organizing information that both humans and machines can understand. So this is how we have worked with adding meaning and insight to our data and how we can come to trust it. So I mentioned before, the organization adopted a 3-step approach to amplify the human capabilities in their service organization. Step 1 involved listening to humans, conducting interviews, workshop, capturing tacit knowledge from experienced technicians. This human-centric method ensured that the solution was grounded in real-world expertise and not a speculative desktop type of exercise. Step 2, focusing on structuring the knowledge that was captured using taxonomies and ontologies, essentially creating metadata out of knowledge. By organizing this information into models, the team created a framework that could be understood and utilized by machines and humans alike. Step 3 was the development of an AI system that collaborates rather than replaces. A large language model was trained on a curated, structured, annotated data set, which enabled it to assist technicians effectively. The AI was designed to act as a knowledgeable assistant, helping technicians feel as they had access to the universal manual. This couldn't have been done without the cooperation of the service technicians, and it could not survive if the mechanisms for continuously evolving and improving the model and the knowledge within weren't established. We implemented this in real workflows. The impact was clear: better service planning, faster issue resolution, and more confident technicians. It was not just a tech project. It was a transformation of how knowledge flows through the organization. In practice, it started with them building taxonomies for product, services, and the industry, a metadata foundation. Then we capture the expert knowledge, how things relate, what to check, what to combine, how to plan for things. This became the foundation for our assistant. We now gave it the guardrails and the structure it needed to be able to answer precisely and correctly. But it was not only that. It was actually starting to create a foundation for all the data in the company, a common foundation with a common language and common definitions and descriptions of what it was. So how did we then apply this foundational work once this was created to the case I described? To the right here, you can see the steps that were included. I will not go into details of those. The overall structure started with a bunch of data and data sets. Many different data sources were utilized, and these all have different metadata and structure. These are the synonyms that I mentioned before. In order to harmonize the data from all these different systems, you need a common language. You need that foundational model that can align across several different systems. So the first step here was to ensure that these systems actually were tagged with the correct metadata. We used machine learning with human validation to tag the incoming data using the structure, as I mentioned before, the meta model, with its different abstraction levels, from generic to very specific, that we designed together with the subject matter experts, the service technicians. The machine learning part here is important to improve the automation element over time, because the machine learning enables a continuous flow of curated, accurate, and validated data that is then populated to the model to be able to improve and relearn. The correctly tagged data was then stored in a new database with proper tagging from the SMEs. This was stored in something called a metagraph. And it was on this new database that the LLMs were trained. A database with a specific purpose, a curated data set, and proper metadata allowed them to train an accurate and precise model with significantly less data than what's needed in a generic LLM, which is a huge benefit because you don't need these big billion pages of data that you need for a large language model, but you can make a specific language model for a specific purpose when you have the guardrails and the structure in place. The result was a system that could answer questions with the accuracy of a technician with over 3 years of experience. So what happened to that perfectly average company? They didn't build a robot to replace their technicians. They built a system to remember them. They built the quiet or they captured the quiet wisdom of those who'd seen it all. The ones who could hear a machine and know what was wrong. They structured that knowledge, gave it shape, gave it language, and taught it to dance with data. And then they built something new, not a replacement, but a companion, a large language model that didn't pretend to be human, but knew how to help one. Now, when a technician faces a problem, they don't feel alone. They feel like somebody handed them the manual the universe forgot to include. And that's the real story, not of machines replacing people, but of machines helping us remember what people are capable of. This wasn't a one-off. This is a model for how we can build AI systems that scale across the enterprise. It all starts and requires good data, good structure, and a human-first mindset. Governance is key. Without it, even the best models fall apart. And this can't be solved in isolation. This is an enterprise-wide mindset. Will this replace technicians? No, it will help them. As the business grows, they will need more of them, not fewer. The entire project, the entire scope here has been about enabling the experts to do what they do best and give them the best prerequisites to succeed. Hiring skilled people to do skilled work is the core here. About the confidence level or trust, any such initiative replacing or rather enhancing humans needs to have a higher degree of trust than the alternative or the status quo. If you have or are at an 85% accuracy today, you need to reach at least 90% accuracy with whatever solution you're adding to have a chance of succeeding in your line of business. I don't have a study backing the why, but that's been my experience so far. You need to have 5 to 10% higher accuracy from the new solution as compared to the current state, while still improving efficiency. Otherwise, adoption will be slow to none. This project showed what's possible when we start small, we think big, and do the right things early. Most importantly, it showed that the best AI starts with listening to humans. Thank you very much for listening.